Hi, welcome to another Level 3 probability distributions video. We're going to now start our discussion on the Poisson distribution. Now, the Poisson distribution is often recognised by a rate. The lower limit is 0, but usually there's no upper limit, hence arising to the symbol infinity and the name Poisson. This is where the name came from, because a lot of people think of the infinity sign as some way people like to draw fish, and the French word for Poisson means fish. Often nicknamed the distribution of rare events. Here are the conditions that must be met for the Poisson distribution. Each event is independent of others. Events must not occur simultaneously. The events must occur randomly, and the probability of an event occurring is proportional to the size of the interval. The parameters for the Poisson distribution, well, there's only one, and it's this symbol here called lambda, and it's the expected value or mean, but it's slightly different because it's the mean over a given time period. All right, let's get into our example. Each year, a region in the Pacific experiences, on average, 2.6 earthquakes that measure over 4 on the Richter scale. So straight away we can see that lambda, which is our expected value or mean, is an average of 2.6 per year. So it's that idea of a rate per something. So it's 2.6 earthquakes per year. All right, here are the conditions that must be met. Let's go through them. Each event is independent of others. So we are assuming that every earthquake is independent of others. Apart from aftershocks, that is generally true. Events must not occur simultaneously. That's true because earthquakes cannot happen at the same time. Events must occur randomly. That is correct. We have no way to predict earthquakes at the moment. And the probability of an event occurring is proportional to the size of the interval. What that means, at the moment, lambda is set up to be an average of 2.6 per year. If we were to change the interval, then lambda would have to change 2. In other words, if I change the interval to 6 months, lambda would be 1.3 per 6 months. Or if I change the interval to 10 years, lambda would be 26 earthquakes on average per decade. All right. Let's get our calculator and go into statistics, distribution, F5, go into further distribution, and you will find the Poisson distribution, which is F1. Now we're going to go into Poisson point distribution and go into variable, and now we can enter in our parameters. Now the first parameter is our lambda. Now on the calculator it calls it mu for average. I don't really like it. I wish they could change it to a lambda, but they've set it up to be a mu. So this is where we're going to put lambda, 2.6. And for now we're going to put 0 earthquakes. We're going to work out the probability of getting 0 earthquakes in a given year. And the calculator gives us a probability of 0.0743. So the probability we have no earthquakes in a given year in that region is 0.0743. All right, well, once again, we're going to set up a probability distribution table. Notice there is no end point because, as we said, there's no upper limit. In other words, there could be 10, 100, 1,000 earthquakes. It's very, very unlikely that'll happen, but we're not going to set an upper limit. So 0, we're going to enter in 0.0743. Let's repeat it and do it for x is 1 and get a probability of 0.1931. Let's repeat it for x is 2 and get a probability of 2 earthquakes in a year of 0.2510. And now let's complete the rest of the table up to 9. Right, here's the probability distribution graph, which gives us a visual representation. Notice the most likely probabilities are somewhere between 2 and 3. That's because lambda is 2.6, and it should be the most common, somewhere between 2 and 3. I like to add on my average onto my graph to visualize it. And notice also that the probability drops off and becomes very, very small as we get further up. As we get to 9, 10, 11, 12, 100 earthquakes, the probability is pretty much 0. Right, well, that's our first video on Poisson, so thank you so much for watching.